All right, this lesson is about the multiplication property of exponents. All right, to start off with, let's just go over a quick thing that tends to get people confused. What is the difference between 4x and x to the fourth power? Okay, 4x, or multiplication, I'm multiplying the 4 and the x. This is the shortcut for writing repeated addition. 4x is the same thing as x plus x plus x plus x. You know, we get lazy. We don't want to repeatedly write something out added together a bunch of times, so we'll change that to a multiplication problem. X plus x plus x plus x is a lot easier to write as just 4 times x. That's what multiplication means. An exponent is repeated multiplication. So if I have x times x times x times x, okay, I have x multiplied together 4 different times, that is the same thing as x to the fourth power. So it's just a shortcut, an easier way to write stuff. But people get these two confused all the time, and that really messes them up later when they're trying to do the multiplication property of exponents. Here's an example of what I mean. I've got x to the 7th power times x to the 3rd power. I used to teach middle school math, and when I was doing problems like this, I always made, for 1 week, I would make my classes write this out with repeated multiplication. So x to the 7th actually equals x times x times x times x times x times x times x. Times, I still have 3 more. And so if I go 3 more times, I figure out how many times I had repeated multiplication. I have x being multiplied together 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different times. And so the shortcut for this is going to be x to the 10th power. Now, you can imagine some different mistakes that people make when they see x to the 7th times x to the 3rd. A lot of times I get people saying, oh, this is x to the 21st power. And it's because their brain is thinking, oh, this is a multiplication problem, so I must have to multiply the 7 and the 3. And think, oh yeah, I've got 21 x's here being multiplied together. Well, that's why I would make my middle school students write this out, and it was so annoying, and they'd start crying and blubbering, snot running down. It was nasty. That's a lie, it never happened. But they would complain because they'd start to realize the shortcut and be like, I don't want to write this out. Do I have to write this out? And I'd be like, yeah, you got to write it out. And then later down the road, when they would make this mistake and they'd have x to the 21st power here, I would say, if I made you write this out, would you have 21 x's here? And like, no, you only have 10 of them. Don't make me make you write this out again. So that being said, let's try a few different ones. If I've got 3 to the 8th power times 3 to the 4th power, what is that? Well, if I'm in middle school and I'm teaching you, this is 3 times 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 3, there's 8 of them, times 4 more. So what does that equal? Well, this is a whole crap ton of 3's being multiplied together repeatedly. How many times were they multiplied? Well, 1, 2, 3, 4, 5, 6, 7, 8. There's my first 8. 9, 10, 11, 12. So 4 more makes 12 total. So this would be 3 to the 12th power. What answers do I see all the time? Well, I see a couple things. I see 3 to the, and they multiply those. 8 times 4 is 32. So I'll see 3 to the 32 power, or sometimes I'll see, 3 times 3 is 9, so I get 9 to the 12th power, or even a 9 to the 32 power, 32nd power. Why is this one wrong? Well, if I go back to my middle school example, do I have 12 9s listed out? I go look at their paper. Are these all 9s? No, those are 3s. So it's not 9 times 9 times 9 times 9 times 9, 12 different times. It's 3, not 9. You don't multiply the base numbers. Okay, so I take this base number, that stays the same, all right? So that's why it is 3 to the 12th power. The base numbers stay the same. The exponents are telling me how many times they got multiplied together. All right, here is a common one that will show up on tests quite a bit. Something like, we've got a 4 on the inside of the parentheses with different variables, all with different powers. And then all of this is in parentheses raised to a 5th power. Okay, well that would mean, if I was in middle school, again, for this 1 week of time, I would make you write this out. This would be 4x squared y to the 6th z to the 3rd multiplied by another one. 4x squared y to the 6th z to the 3rd times another one. 4x squared y to the 6th z to the 3rd. And I keep going 5 different times. And then we go and find out all the 4s. Well, how many 4s would there be? There better be 5 of them. So there should be 4 to the 5th power. How many x's are there going to be? Well, there's going to be an x squared, another x squared, another x squared, 5 different times. So total, that should be x to the 10th power. And then we have y to the, how many of those are there going to be? Well, it should be 30 of them total. And then z, 5 different times. So 3 times 5 is going to be 15. And so after a week of doing this, I start asking my students, and I don't even have to, they're already telling me, what are the shortcuts? When I have a parenthesis and there's a power on the outside, so basically I'm saying I have an exponent raised to another exponent, or a power to a power. What's the shortcut? How did this 4 to the 1 power end up turning into a 4 to the 5th? And how did this x squared turn into an x to the 10th? Y to the 6th turn into y to the 30th? And they pretty quickly find out the shortcut. The shortcut is anytime you have a power to a power, you multiply this outside exponent to all the exponents on the inside. This 4 right here has an invisible 1 power. So 5 times 1 is 5. That's why it's 4 to the 5th. X squared being raised to a 5th, I multiply power to power, and that becomes x to the 10th. Multiply them, y to the 30th, z to the 15th. So what's the rule? If I am multiplying bases together and the base is the exact same thing, we add the exponents together. If you have a power to a power, so an exponent being raised to another exponent, we would multiply those. If you have the same base and you are dividing the bases, so like let's say we have x to the 10th divided by x to the 3rd. Okay, that's very similar to this top one. This was multiplying. When you multiply the bases, you add the exponents. So what would you guess would happen if I'm dividing the same exact base? We'd subtract, yes. So the bases are the same, so we subtract the top one minus the bottom one, and that would end up being an x to the 7th. All right, that's just a quick little explanation on the multiplication property of exponents, also going over how to do a power, since it's basically the same exact thing. If you have any questions, let me know. Leave a comment down in the comment section, and I'll get back to you as quickly as I can. Give this channel a subscribe and a like, and we'll see you soon. Have a good day.